Well, it's now day 3 for the notes. Day part 2, I guess, if you want to call it. So we are in, I'm going to stick it over here. Get my board to work for me. So notes. Module 1, topic 2, lesson 1, and if you want to call it part 2, you can, or it's just a continuation. So we're on page 117. We're not going to get into too much here on 117. I want to just sit here and talk about, real quick, I'm not sure where that green came from. I want to talk about a couple of the definitions on here. So again, a reminder, a linear pair of angles are two adjacent angles that have non-common sides that are opposite rays. So basically, the example here for angle 1 and angle 2. All right, and they are a measure whose sum is 180 degrees. So they have to have an adjacent side, okay, or a shared side, it's sometimes called. So, in here. So this one is called the shared side. Okay, and that's why they're adjacent. Where their non-adjacent sides are opposite rays. So they kind of go off in opposite directions there. So just for an example of what is not a linear pair, so not a linear pair okay, is something that looks like this. Okay. So if this was angle 1 and angle 2 here, yes, they have a shared side. But their non-shared angles or their non-shared sides are not opposite rays. They are rays, but they're not opposite rays. Okay? So this is an example of what are called adjacent angles. So they're not a linear pair, but they are adjacent. All right. Another thing we need to talk about, just to kind of refresh memory here, and I'm just going to kind of use this space down here. I'm not going to go into anything else going on here. Okay, is that they something called vertical angles. Vertical angles come up all the time in geometry, and so we need to talk about them. Vertical angles are formed by two intersecting lines. And they are the non-adjacent angles. So vertical angles have those properties. They're formed by two intersecting lines and they're non-adjacent angles. So for example, okay, I have two intersecting lines here that make 4 angles. 1, 2, 3, 4. But 1 and 4 are adjacent. 1 and 2 are adjacent. 1 and 3 are non-adjacent. So 1 and 3 are vertical angles. So for our example here, angle 1 and angle 3 are vertical angles. And angle 2 and angle 4 are vertical angles. And a little side note, because of the fact we know the relationships of two intersecting lines, and you can consider the fact that if I was to draw a circle, I'm not going to get a compass out, but if I was to draw a circle here, okay, and this would be the center of my circle, I'm not even saying that these are perpendicular at all, but the relationships of the arcs with the secants going through the circle, then I can sit there and prove that angle 2 and angle 4 are congruent, and angle 1 and angle 3 are congruent. So therefore, vertical angles, I'm just going to label it VA, are equal measure. Okay, so any vertical angles that you find are always going to be equal measure. Okay, and congruent. That should be a little squiggly there, not just a line across. Okay. All right, so just some definitions. Again, this is a lot of definitions and a lot of information and that sort of thing in this topic. All right, so now we're going to go into inscribed angles. Yesterday we kind of talked about, or the previous notes, we talked about central angles. Now we're going to talk about inscribed angles. So here's the definition of inscribed angles. It's an angle whose vertex is on the circle and whose sides contain chords of the circle. Notice now this is drawn with the lines extending out, but we're just looking at the angle part of it. So it's this part right here is the inscribed angle. Okay. So the key thing is that the vertex is on the circle. All right, so if I'm looking at this, it tells me that the vertex, so if I kind of scroll down here, the vertex of PMD, so I'm looking at PMD, looking at this angle here, PMD. So I'm looking at that, is on a circle. M is on the circle. The two rays of the angle intersect points, the circle at points P and D. This makes PD an intercepted arc of PMD. An intercepted arc is part of a circle that lies on the interior of an angle with endpoints that are intersections. So basically they're just saying that this distance here, or this arc here, has a specific name of being an intersected or intercepted arc. Okay, so they'll sometimes talk about that. All right, now, okay, down here it says central angle POD also intercepts arc PD. Compare the measures. Okay, so now we're going to look at this. Okay, so POD, so POD is this one here. Now we know that we are told it's a 90 degrees. This is a linear pair going on here. So if this side is 90 degrees, then that means this side also has to be 90 degrees. So we know that the measure of angle POD is equal to 90 degrees. Now, we also know that central angles are equal to their arcs. And we know that arc PD is the intercepted arc of angle POD. So that means that PD, arc PD, has to also equal 90 degrees. Okay, so we know this distance here is 90 degrees. Now, yesterday in our notes, we talked about how we made this triangle, and we were able to prove and measure that this was a 45 degree and 45 degree. So that means that we have arc, the measure of angle PMD is equal to 45 degrees. And PD is an intercepted arc of angle PMD. So POD is a central angle, PMD is an inscribed angle. Inscribed angle. And we know that the angle is half of the arc. Okay? So that means, unlike central angles that are equal to the arc, inscribed angles, it's spelled, so inscribed angles are 1/2 their intersected arc. Okay. All right, and that basically answers what we talked about too down there. We're not having to go back and forth, up and down. Okay. All right, so when you have a central angle that's equal to the arc, an inscribed angle is half of the arc. Okay, so let's go on to page 119. So we went from 117 or 118, sorry, to 119. Right, and I'm just going to kind of use this space down here to kind of clarify and make sure everybody is good. So you don't have to get fancy about it. Just kind of draw a circle. Mine kind of looks more like an egg. And we are going to just draw some angles here, because this is something that comes up all the time. On different types of test questions and that sort of thing. Okay. All right, so I have two inscribed angles here. I'm going to label them Y, X, M, and Z. Okay. So I know that angle Y, X, not Z. Come on. Y, X, Z is an inscribed angle. Okay. And I am told that the measure of angle Y, X, Z is equal to 30 degrees. So I know this one here is equal to 30 degrees, which makes arc ZY equal to 60 degrees. Then in turn, that means that the measure of angle YMZ is also 30 degrees, because YMZ is an inscribed angle that intercepts, arc Z, whoops, arc ZY. So you can kind of use the kind of a little bit of like a chain rule here. If you know that one angle is 30 degrees and it's an inscribed angle, then its arc is 60. Therefore, if it has another angle that intercepts that same arc, then it's also going to be 30 degrees. And so you can have congruent angles in that sense. Okay, so that's a little bit like a homework problem. All right, the one last thing I want to talk about, so just keep in mind your homework tonight is going to be dealing with inscribed angles and central angles. So central angles are equal to the arcs. Inscribed angles are half of their arcs. The only other thing is just a little vocabulary. You're not going to get into it too much, but there is this thing called the tangent, and it is a line that intersects a circle in exactly one spot. And it's called the point of tangency. Okay, but I wanted to kind of point this out. Okay, a little bit of information about this. If I can get my pen to go a little bit smaller, would be great. Okay, so in this diagram here, it's kind of a little bit confusing what's going on here. So MQ, line MQ, is tangent to circle P. Okay. Q is the point of tangency and PQ is the radius and MQ is perpendicular to PQ. Okay. So anytime that you're told you have a line that is tangent, then that means that at that point of tangency, the radius from that point of tangency is perpendicular to that line of, or that tangent line. Okay, so kind of like here, you have this circumscribed angle, which has two sides that are tangent to the circle. So they're talking about this angle way down here. It's the circumscribed angle. Notice how at the points of tangency you have 90 degrees, which starts building in a lot of information about quadrilaterals and stuff that we're going to deal with next week. So just keep in mind that when you have a circle and you have a tangent line, that point of tangency to the center of the radius is perpendicular to that tangent line. Okay. All right, so tonight your homework is basically all on central angles and inscribed angles, being able to calculate them.